This video covers section 5.3, Polynomials and Polynomial Functions for Math 95 at Linn-Benton Community College. Our goals for this section are to learn a bunch of vocabulary, define polynomial functions, review combining like terms, and then finally add and subtract polynomials. This is an example of a polynomial. 3x to the fourth minus 4x squared plus x minus 7. It's also known as a polynomial in one variable, or a polynomial in the variable x. Most of the polynomials that we will work with in this class are in one variable, so we're just going to call this a polynomial. All polynomials are going to look something like this. There will be x's raised to different powers with coefficients being added together. Let's try writing down a few more things that follow that sort of pattern. Something like x squared minus 3x plus 2 would be a polynomial. I could have negative 5x to the 10th plus 2x squared minus x. And that would be a polynomial. Let's come up with one more. How about 4x to the 42nd plus 2x squared plus 1. All of these are examples of polynomials. Let's go back to looking at that first example, 3x to the fourth minus 4x squared plus x minus 4. This polynomial has four terms. A term is a number or a variable, or the product of a number and variables. So a term is something held together by multiplication. It's a bunch of stuff that's being multiplied together. Let's write down the four terms from this polynomial. The first term is 3x to the fourth, since we have 3 being multiplied by 4 x's. The second term is negative 4x squared. I've got a negative 4 being multiplied by 2 x's. Then I've got the term that's just the x, and finally the term that's just the negative 7. So each of those is a term in this polynomial. Factors are things that are connected by multiplication, whereas terms are separated from each other by addition or subtraction. For instance, the factors in the term 3x to the fourth are 3, x, 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 and x. 1, 3, and 4 x's are the factors of 3x to the fourth. Similarly, the factors in the term negative 4x squared are negative 4, x, and x. Do you remember what a coefficient is? A coefficient is a number that is being multiplied by a variable. Let's identify the coefficient in each term of this polynomial. Remember that the four terms here are 3x to the fourth, negative 4x squared, x, and negative 7. In this first term, I have a 3 being multiplied by the variables x. So the coefficient is the number 3. In negative 4x squared, the coefficient is negative 4. This next one is a little bit tricky. The x is all by itself, but you can always think of there being a 1 multiplier in front. I like to call that a ninja 1 since it's hiding and you can't see it. Now looking at this last term, the negative 7 doesn't have a variable with it, which means that technically there's no coefficient here, since a coefficient has to be being multiplied by a variable. However, that's a technicality and not something you should spend a lot of time worrying about. The big idea is that the coefficient of a term will be the number part and not the variable part. That final term that doesn't have a variable, though, is sort of special because it's the only term that doesn't have a variable. Because there's no variable, we call it the constant term, or constant for short, since it doesn't change. You've probably encountered the prefixes mono, bi, tri, and poly just in your use of the English language. Let's take a minute and come up with an example for each of those to help you remember what they mean. Mono means one, like a monocle that has only one lens, or a monopoly where one company controls an industry. Bi means two, like a bicycle that has two wheels. Similarly, tri means three, like a tricycle, which has three wheels. Poly means many, such as polytheism, the belief in many gods. This all applies to our polynomials because we're going to use mono, bi, tri, and poly to talk about how many terms there are in a particular polynomial. A monomial will have only one term. So, for example, negative 3x squared is a monomial, or x, or 7, or negative 42x squared y to the 7th. Each of those are monomials because there's just one term in each one. A binomial has two terms. So for instance, x squared plus 1 is a binomial, or x minus 7, or 3y plus 2x. Each of those are binomials because they each have two terms. And of course, a trinomial will have three terms. So something like x squared plus 2x minus 7, or 3x squared plus 4y plus 2. Each of these is a trinomial because they have three terms. Any of these things, monomials, binomials, trinomials, and so on, can be called a polynomial. Now that we've built up that vocabulary, it's time to actually define a polynomial. A polynomial has one or more terms where the coefficients of each term are real numbers and the exponents of any variable are non-negative integers. What that means is that the exponents are always going to be very nice numbers, things like 2 or 7 or 12, but they'll never be negative and they will never be fractions. So let's solidify that by looking at three examples of things that are not polynomials and talk about what's wrong with them. The first one I have is 3x to the negative 2 plus 7x minus 8. Now, there are three terms here, but this x to the negative 2 is a problem. That negative exponent makes it not a polynomial. This next one is x to the 5th minus x to the 1/2 plus 5x. This one also has an exponent problem because it has a fraction for an exponent. Remember that that would translate as the square root of x. That's definitely not something that we want in our polynomial. And finally I have this example, the square root of negative 4 times x cubed minus 4x squared. Now all of the exponents are okay here, but the square root of negative 4 is not a real number. This is not a polynomial because for a polynomial we want only real coefficients. Now that we've actually defined what a polynomial is, we're going to continue exploring them and learning some more vocabulary to go with them. First up is the idea of degree. If a polynomial has one type of variable, then the degree of a term is the value of the exponent for that term. So, for instance, here's a polynomial. We're going to write down the degree of each term. And this is good practice because it means that we're first going to have to figure out what each term is. The first term is negative 2x to the 5th. The second term is 3x squared. The third term is negative x. And the last term is 7. Now that I know what each of the terms is, let's figure out what the degree of each term is. The exponent in negative 2x to the 5th is 5, which makes the degree 5. In 3x squared, the exponent is 2. The last two, of course, are a little bit more tricky. This negative x doesn't appear to have an exponent, but you can always think of anything by itself as being taken to the first power. So the degree of negative x is 1. Similarly, there is no x here with the 7, which makes the degree of the constant term 0. Finally, the degree of the entire polynomial is the degree of whichever term has the highest degree. We call that term the leading term, and its coefficient is called the leading coefficient. It's a really good habit to write polynomials in descending order so that the leading term is always in front. Looking back at our example, the leading term was negative 2x to the fifth, which means that the leading coefficient was negative 2, and the degree of this entire polynomial is 5. Okay, here's the weird thing. Let's say that you have a polynomial in more than one variable. So you've got both x's and y's playing around. Then the degree of each term is the sum of the exponents of the variables in the term. We're going to do an example here and find the degree of each term of the polynomial. First, we better figure out what all the terms are. My first term is 3x to the fourth y cubed. My second term is the next group of stuff that's being held together by multiplication, so 4x squared y cubed. My third term is the next group of stuff being held together by multiplication, so negative 7xy, and my last term is the constant term 8. So essentially what we want to do here is count the number of variables in each term. This term has 4 x's and 3 y's for a total of 7 variables. This term has 2 x's and 3 y's for a total of 5 things. This term has 1 x and 1 y for a total of 2 variables, and the constant term 8 has no variables whatsoever. Now that we've found the degree of each term, it's easy to find the degree of the entire polynomial, since it's just the highest degree of the terms. Now I have one for you to try. I'd like you to take this polynomial, identify each of the terms, and tell me what the degree and the coefficient of each term is. You may want to pause the video while you write down your answers. Okay, I hope you took a moment to think about that problem. This polynomial has 5 terms: negative x to the sixth, 12x to the fourth, negative 6x squared, x, and 9. The degree of negative x to the sixth is 6, since the power on the x here is 6. And similarly, the degree of 12x to the fourth is 4, of negative 6x squared is 2, and of x is 1. Since there are no variables with the 9, its degree is 0. The coefficient on negative x to the sixth is negative 1. Again, you can think of there being a little ninja 1 in there to help you out. The coefficient of 12x to the fourth is 12, of negative 6x squared is negative 6. The coefficient of a single x is 1, and the idea of a coefficient is not really applicable to the constant term. Now that we've mapped out the degree and coefficient of each term, we can easily say what the degree of the polynomial is and what its lead coefficient is. The degree of the polynomial is 6, since that's the term with the highest degree. The term with the highest degree is negative x to the sixth, so the coefficient of that term is the leading coefficient, negative 1. Okay, there's a lot of vocabulary in this chapter, so let's move on to doing something with these polynomials. First, I'd like to point out that polynomials are expressions, not equations. They don't have an equal sign in them. So we can't solve a polynomial unless we set it equal to something, like another polynomial, or set it equal to 0. For example, I could take this polynomial and set it equal to this other polynomial. Now I have an equation. Polynomials are also functions, so we can give them a name and then evaluate them by plugging in values for x. I want to repeat what I just said about polynomials being functions. All polynomials are functions, so you don't have to worry about it. Every polynomial that you encounter, you know is a function, so each input will have only one output, and the graph will pass the vertical line test. Let's look at one particular polynomial function. A lot of times we name our polynomials p. So this is the function p of x equals negative x squared plus 5x minus 6. And I would like to evaluate it for x equals 2, or I would like to find p of 2. Now remember, this function notation just means that I'm going to plug in 2 for the x's. So when you're asked to evaluate a function, that usually means you're going to plug in a particular number for the variable. and then simplify to get a number as an answer. So here I'm plugging 2 into my polynomial here, which leaves me with 2 squared is 4, and the opposite of that is negative 4. 5 times 2 is 10, and then I have a negative 6. When I add all this stuff together, it looks like I'm going to get a 0. That means that P of 2 equals 0. Or when I plugged in the value 2 for x, I got the value 0 out for y. Or the point 2, 0 is on the graph of the polynomial. When we're not evaluating polynomials, we can add or subtract them by combining like terms. Remember that like terms are terms with exactly the same kind of variables. Let's look at an example. I have 3x squared minus 7x plus 1, and I would like to add 7x squared plus 8x minus 2. Now, since what we're doing here is addition, I can go ahead and drop these parentheses. I have 3x squared minus 7x plus 1 plus 7x squared plus 8x minus 2. Now let's identify the like terms. Like terms have exactly the same variable parts, but the coefficients are likely different. For instance, 3x squared is a like term for 7x squared, since they both have x squareds. There's another two terms that only have x's, the negative 7x and the 8x. And finally, the two constant terms are like terms, 1 and negative 2. So I can go ahead and combine those to give me 10x squared. The negative 7x plus the 8x will give me plus 1x, and 1 plus negative 2 will give me a negative 1. In the next example, we're going to do some subtraction, and we'll have to be a little bit more careful when we do subtraction than when we do addition. Here I have 3a squared plus 8a minus 7 minus 5a minus 3. Now, that negative applies to both of the terms over here. So this is really 3a squared plus 8a minus 7 minus 5a plus 3. Because subtraction is addition of the opposite, so I'm going to add the opposite of negative 3. Or you can think that a negative and a negative make a positive. You can also think of distributing that negative 1 out front to both terms. Now that we've taken care of the negative sign, we can see if there's any like terms to combine. One of my terms is a 3a squared, but there's no other a squared things, so looks like it's the only one. Then I have an 8a and a negative 5a, so I'll be able to combine those. And I have a negative 7 and a positive 3, which I'll be able to combine. That will give me, in the end, 3a squared, 3a, and negative 4, since negative 7 plus 3 is negative 4. Now I have a couple of problems for you to try. Before you pause the video, I want to point out the directions on this one. It says subtract 8y squared plus 4x from y squared plus x. That means that you're going to take this and subtract this. So now you may want to go ahead and pause the video, give these problems a try, and then we'll come back and look at them together. And we're back. So for this problem, subtract 8y squared plus 4x from y squared plus x means that we'll take the y squared plus x and subtract 8y squared plus 4x. Again, with subtraction, you have to be a little bit careful. That subtraction applies to both pieces here. So you need to distribute that negative to both terms. That gives me y squared plus x minus 8y squared minus 4x. And now I can finish by combining like terms. Here I had a single y squared and a negative 8y squared. Combine those to get negative 7y squared. And then I had an x and a negative 4x. Combine those to get negative 3x. The second problem was adding two polynomials together. So we have our first polynomial and our second polynomial. We start looking for like terms. Here I have 6x squared plus another x squared, which gives me 7 total. 5x plus 6x is a total of 11x, and 7 minus 3, or plus negative 3, will be 4. The last thing that I want to do is remind you that you could graph a polynomial. You could pick several values for x, make a table of values with x's that you plug in and find the corresponding y value, and then you could plot those on a graph and connect them up. We won't spend a lot of time on graphing polynomial functions in this class, but you should be aware that you can graph these functions and that it's just a matter of plugging in a bunch of x values, finding the corresponding y values, and connecting those dots up with a line. Now, graphing is something that your calculator does very well and very quickly. So let's look at a couple of graphs generated from a calculator. I have 7x cubed minus 2x squared plus 8, and you can see this polynomial, it goes up to the right and down to the left, and it kind of makes an interesting little wobble in here when it crosses the y-axis. Here I have x to the fourth minus 2x cubed minus x plus 9, and this one looks sort of like a parabola, except for this funny little dive that it does instead of being nice and rounded. This section had a lot of vocabulary. It's important that you become familiar with that vocabulary so that you know what we're talking about as we continue to study polynomials. It's also quite valuable to be familiar with the vocabulary so that you can understand what a question is asking you to do. This might be a good opportunity to make some flashcards to help you learn that vocabulary. Other than the vocabulary, this section really only had two big skills for you to learn. One was evaluating the polynomial, which you actually knew how to do already, since that just means plugging in a number for x and finding out what the y value is. And we also looked at adding and subtracting polynomials, which you sort of knew how to do already because you remember how to combine like terms. So go out there and learn that vocabulary, and good luck with your homework.